Hey everyone, it's Hax. I know a lot of people have been waiting for this video in which I'll finally reveal the details about the box. Exactly a year ago from today, I learned that if I ever wanted to play Melee again, I'd need an entirely different controller. At the time, Hitbox was making waves within the Melee community with their latest product, the Smashbox. Advertised as an ergonomic controller that gave its user perfect control, the Smashbox was nothing short of revolutionary. With nothing to lose, I reached out to Hitbox. A few days later I received a Smashbox in the mail. By then I'd already given it some thought and I could tell that what they'd sent me was a prototype at best. Riddled with design flaws, the Smashbox didn't live up to the hype, but the potential was there. I began working day and night to get the controller into working shape, but as the weeks went by it became clear that Hitbox didn't have the same vision in mind, so I broke away to create my own version of the product. Back then I had no idea how long this would end up taking me. By summertime, I realized that the consistent performance of the controller I was playing on made Melee a lot better, and that a software update to the game was actually needed. This was a radical idea at the time. In fact, I had gone against it in the past, but I knew that it was time for change. I would end up going a bit overboard with the mods I proposed, and in hindsight I was too stubborn to give the community what they wanted. Still, people saw merit in the idea, and we were able to end up with a mod that corrected some of my mistakes. It would go on to become the tournament standard. These advancements eventually called for some of our first rule set changes in years. In August, Melee and Onmi revealed a rule set they'd be running at several major tournaments. This included a tentative ban on box controllers, with a lack of information being cited as the reason. While this is completely understandable, it also isn't hard to tell that the members of MIOM have philosophical issues with box controllers. Naturally, the digital inputs of a box raise concerns when it comes to Melee, a game that was meant to be played with an analog stick. Fortunately, before this document was written, I had already begun to take a different approach with the box. That's because I was starting to become concerned with the box myself. Hitbox had been pushing the notion that one input, one output, in other words, no macros, was all it took for a controller to be fair. But while this may be true for other games, many people were skeptical when it came to Melee. As time went on, I found myself agreeing with it less and less. A controller can be advantageous in ways that don't involve macros, and the box had a few of them going for it. One of Melee and Onmi's philosophies is that the Gamecube controller's intrinsic difficulties should be upheld by any third-party controller. I definitely agree with this, not necessarily because it's the controller Melee deserves, but because it's too ingrained at this point. At this stage in the game, it wouldn't be fair to release a controller that people felt they had to switch to. For this reason, I base the box around what's humanly realistic to do with a Gamecube controller. I've spent the past few months designing a patch and creating a rule set that I believe box controllers should have to abide by. These will be the focal points of the video. This also solves a few other problems. For one, the box needs standardization. If needed, it'll be easy to verify that someone is running the legal patch. This also eases concerns with the precedents set by legalizing box controllers. By clearly defining what this controller does, we're able to limit its capabilities and close the can of worms. Before I can move on, there are two things I need to address within this document. In the first paragraph, the document states that notches do not provide meaningful advantages. This is inaccurate. At the moment, all case mods are tournament legal, which will play a small role in the video. And then, in the fourth paragraph, the document seems to suggest that a third-party controller shouldn't be allowed any advantages over the Gamecube controller. While I agree that the box should have to be in line with the Gamecube controller, this is an overly conservative mindset. In most games and sports, people are allowed to choose from different equipment. There are bound to be minute differences between these models, but that doesn't mean they can't coexist. It wasn't even until recently that the Melee community fixed some of the biggest problems with Gamecube controllers. Clearly, a controller shouldn't have to be obsolete in every way. I'm bringing this up because the end goal isn't to create a perfect replica of the Gamecube controller. Some advantages inherently can't be removed, and the same goes for some disadvantages. That being said, I do believe the controller I'll be showing you is fair and should be tournament legal. On the grid of the Gamecube control stick, there are 9 sections. These would be the dead zone, the 4 cardinals, and the 4 quadrants. On each axis, there are thresholds for tilts and smashes. On the x-axis, this would be 0.8. On the y-axis, it's 0.6625. These are also the relevant cutoffs for things like dash, pivot, tap jump, and shield drop. There's also a 50-degree line that separates a few things, like angled forward tilts. On each axis, 0.7 is the cutoff for roll and spot dodge. All controllers should have to abide by a one-to-one remapping of the Gamecube controller. Only modifier buttons are exempt from this rule. This means that the box can only have one of each cardinal direction. It's fine for opposite cardinals to override each other since that feels the most like a control stick. Also worth noting are the physical locations of the buttons. The up button's placement may come as a surprise, but it makes sense when you think about it. If up were to go here, you'd have to pick up your left hand just to reach it. This location doesn't amount to anything advantageous, it just makes the controller a lot more comfortable. In general, I don't think it's healthy to demand buttons in poor locations, but I know that something about this controller will be targeted, the positioning of the C-stick. Having access to the C-stick at all times lets you do things like drift your aerials and ASDI down while moving. These would seem like advantages over the Gamecube controller, if you hold it with the intended grip. Over the years, we've seen players look for the most advantageous controllers possible, but something people rarely talk about is how the Gamecube controller should be held. When Javi first came to the States, he caught everyone's attention for using it as if it were a fight stick. Ever since then, this has flown under the radar, but I actually believe this is a very advantageous grip. The Javi claw allows for perfect control over the C-stick while also feeling natural. Its only downside is that it slightly compromises the R button, but even then, it's still within reach. In the end, the location of the C-stick is an unfortunate reality of the Gamecube controller, but it would be a mistake to use this against the box. This would set the precedent that only the Gamecube controller can be legal, since no modern controller will have its buttons in poor locations. A box controller operates like a keyboard. It has 4 arrow keys, but these only let it pinpoint 8 coordinates on the entire grid. The significance of this is that it identifies which section of the grid you're in. From there, modifiers can be used to select any coordinate within that section. These can be thought of as shift keys. For example, if you press right in conjunction with a modifier, you can walk instead of dash. Modifiers are needed for several in-game techniques. They are what allow box controllers to function. Modifiers do need to be regulated. They are not allowed to change the section of the grid you're in. They're also not allowed to pinpoint band coordinates, which I'll be going over throughout the video. These are the areas of the game where I felt that the box had too much of a precision advantage and shouldn't be allowed to perform certain techniques. Lastly, any button on the controller can serve as a modifier, although this has to be evaluated on a case-by-case basis. The Smashbox didn't have this feature whatsoever, but it's integral to the design of a box controller, and the main reason I was able to go from 4 modifier buttons to 2. To give you an example, pressing L down and left on the box automatically gives you shield drop coordinates. L is the modifier in this case. This makes the box feel like it has shield drop notches and isn't harmful whatsoever. Later in the video, I'll show where else the box does this. One of the most common rumors about box controllers is that the analog directions don't have an actuation time. This would seem to be the case since they skip straight from 0 to 1.0, whereas the Gamecube controller gets pulled along the way. A lot of people thought that this meant the box had a frame 1 dash. To verify whether this is true or not, let's take a look at some of the specifics. Melee runs at 60 FPS, which means that a frame is 16 2/3 milliseconds in real time. Let's say theoretically it took the Gamecube controller 8 1/3 milliseconds to dash, meaning from the point in time you decide to move your stick, that's how long it takes for it to reach dash. This would give you a 50% chance of dashing on frame 1 and a 50% chance of dashing on frame 2. That's because if you start this motion during the first half of a frame, it'll complete in that frame, but if you start it during the second half, it'll cross over into the next frame. What this also means is that the only actuation time with a 100% chance of a frame 1 dash is 0 milliseconds. This is physically impossible. On the box, once you decide to dash, your finger has to physically reach the button and activate it. This takes time, but it's difficult to tell how long. With a Gamecube controller, you can use an oscilloscope for a better idea of when the motion starts. Since the box is digital, this can't be done. This means that the best way to compare the two controllers is to have the same person activate them simultaneously. This won't give us exact measurements, but it's good enough. Before these tests can be performed, a few assumptions have to be made. I'm going to be activating both controllers swiftly and comfortably as I normally would. My left thumb is on the middle of the Gamecube control stick, and my right index finger is a few millimeters above the button. The Gamecube controller is fairly new and doesn't have any PODE. I'm also going to assume UCF is on. The x-axis thresholds are also going to be relevant here. I'll go over the possible outcomes. When you dash forward, if you're pulled in X smash, the dash will initiate, but Fox won't move on the first frame. On the second frame, he'll move approximately 2 units. If you get pulled in X tilt, you'll move a small distance on frame 1. Depending on where exactly in X tilt you're pulled, this will vary by a little bit, but it averages out to 0.2 units. On frame 2, Fox will dash, but this time he'll move another 0.2 units. Then on frame 3, he'll move 2 units. The box cannot receive this outcome since it never travels across X tilt. For dashback, UCF makes it so that it doesn't matter whether you're pulled in X smash or X tilt. Both will cause Fox to turn on frame 1. Dash will start on frame 2, and then he'll move 2 units on frame 3. For the tests, all I did was dash forward 50 times with both controllers. This tells us everything we need to know since we can extrapolate these results to assess dashback. Ultimately, there's variance with this method of testing, but the positive trend in favor of the Gamecube controller is obvious. The advantage stems from the fact that when you use the Gamecube controller, your thumb is on its stick at all times. I can provide footage of this test to anyone who wants it. In Melee, the furthest the X and Y axes go is 1.0. This is the best value you can have in certain situations. For example, when Fox dashes at 1.0, he'll peak at an acceleration of 2.2 units per frame. If he dashes at the value before 1.0, he'll peak at 2.17. The 1.0 cardinal is notable because reaching it isn't so simple. On the grid, it is only 1 pixel. To put that in perspective, 0.9875 has a wide range of pixels. Since the box is digital, this doesn't matter. It can pinpoint 1.0 every time. This wasn't nerfed for 3 reasons. 1. The box is already at enough of a movement speed disadvantage. A lot of people jumped the gun when it came to the 1.0 cardinal, but no one really considered what I showed you in the last section. Compared to the frame advantage the Gamecube controller has, the 1.0 cardinal is almost irrelevant. 2. This isn't a box exclusive advantage. In the Gamecube controller project video, I showed a controller that hit the 1.0 cardinal every single time to the left. This actually isn't that hard to find, it just hinges on 2 things. The first step is using a controller with a sharp case. A sharp case is an advantage regardless of the 1.0 cardinal because it locks your stick into place. This removes almost any chance of you getting less than 0.9875. The second step is finding a controller with 1.0 cardinals that align with your case. This is the harder part. Most controllers suffer from stickbox rotation, which will offset your 1.0 cardinals. Stickbox rotation is also the reason some controllers will shield drop fresh out of the box. Because the shield drop values are so close to the southwest and southeast corners, the slightest manufacturing error can align them in a favorable way. 3. The 1.0 cardinal should be fixed in UCF. At this point it should be obvious that there's a problem with the 1.0 cardinals. Sometimes when I bring this up, people will tell me that UCF shouldn't fix them because UCF's goal is to bring your controller in line with the best controller, and 1.0 in all 4 directions might not even exist. It's a bit misleading that UCF presents itself this way. UCF claims that all it does is bring your controller in line with the best one, but the logic behind it actually runs deeper. What UCF does is it redesigns areas of the game where controllers can't perform consistently. This is different because it doesn't hide the fact that it improves your controller. This is most obvious with UCF's dashback fix. UCF fixes dashback by giving everyone 100% dashback, which no controller ever had. Similarly, UCF needs to fix the 1.0 cardinal. I recommend turning the values 0.9625 and above into 1.0, since those are cardinal exclusive. Smash DI is a mechanic that lets you move your character during hit lag. I consider it important that the box's Smash DI is in line with what's realistic. There are a few laws of Smash DI, but the main one is that you have to either maintain or gain vectors. A cardinal is 1 vector and a diagonal is 2 vectors. This means that you can SDI by going from cardinal to cardinal, cardinal to diagonal, or diagonal to diagonal, but you can't SDI by going from diagonal to cardinal since you'd be losing vectors. In theory, here's what the best SDI would look like. You would start in the cardinal and then you'd alternate the adjacent diagonals on every frame. At a human level, this isn't even close to possible. With the Gamecube controller, there are 2 optimal ways to SDI depending on the situation. The first method is quarter circle SDI. Start in the cardinal, then go into an adjacent diagonal. You should always SDI twice by no later than frame 4. Quarter circle SDI is good because it can be done at any time, but if you're able to slightly adjust your grip on the controller, there's a better method. Wank SDI is the best way to SDI on the Gamecube controller because it removes the need to time your inputs. It's done by situating the stick against the rim with your left thumb and vibrating the controller with your right hand. This will generate SDI every 4 frames and can be done indefinitely. The disadvantage is that it requires preparation, but if you can set it up, it's the best choice. On the box, for the most part, there's only one way to SDI. Since the arrow keys have no travel time or recoil, you can use 3 of them to SDI 3 times in as fast as 3 frames. This isn't broken, but it's definitely excessive, so I decided to tone it down. In Melee, the vast majority of moves deal 20% or less. This means that we're looking at hit lag windows of up to 9 frames. One of the laws of SDI says that you can't SDI on the first frame of hit lag, which leaves us with 8 frames. Now let's say you SDI twice on frames 2 and 3. The box has been programmed to recognize this. On the box, when you press a horizontal followed by a vertical, the other vertical is locked out for 6 frames. This limits you to 2 SDI inputs per hit lag window, which is in line with quarter circle SDI. The box still has the advantage of performing the second SDI slightly faster than the Gamecube controller, but overall this is much more reasonable. There's only one way to exploit this programming and get a third SDI input. It involves a technique known as double tapping, which is when you use your middle and index fingers to press the same button twice. Similar to Wank SDI, this requires a different grip on the controller. With this method, you can activate a cardinal twice on frames 1 and 4, and then a diagonal on frame 5. In the end, I decided that this did not need to be nerfed. Between the need for preparation and the fact that you still have to time your inputs, I find this technique very unreliable. If that changes, I'll take another look at it. Shield drop is an interesting case. In the game's code, the zone for it is huge, but in what was likely a rushed decision, spot dodge was placed directly on top of it. This left shield drop with only 3 Y values. Because of this, there are 2 ways to shield drop. The first method involves notching your controller so that the corners are aligned with the shield drop values. From there you have to shut off roll, which can be done in a few ways, such as dashing. Then go along the rim and into the notch. This is the only way to shield drop swiftly and consistently with the Gamecube controller. The second method is to point directly down at the shield drop values. In theory, there's no reason not to do this every time. This is the fastest way to shield drop in the game since it doesn't waste time shutting off roll. The problem is that this can be done as early as frame 2, which is extremely unrealistic with the Gamecube controller. Digital inputs are at an advantage when it comes to shield drop down. The key to removing this from the box lies in the order of priority within the game. If chosen on the same frame, the game will prioritize spot dodge, then roll, then shield drop. If its shield drop coordinates are paired with roll coordinates, the box is forced to shut off roll in order to shield drop. This means that the box objectively can't shield drop down. Unfortunately, this is the only fair compromise. To pivot in Melee, you have to enter X smash, then escape it on the next frame. There are 2 ways to do this on the Gamecube controller. The first method is a flick pivot, which is when you move your stick to the side and release it. The second method is a quarter circle pivot, which is when you go along the rim. To perform pivot tilts as fast as possible, you'll need the zones in the middle of the control stick. The box can reach any of these, but the Gamecube controller will have to be evaluated on a case-by-case basis. For pivot forward tilt, the best method is to flick pivot and press A when the stick is on its way back to the center. The box is slightly more reliable than the Gamecube controller at pivot forward tilting, but overall it's okay for it to have this. Angled forward tilts are interesting because they're the only ones that come into contact with the rim. Not many people know about this, but these can be notched. You can test this out by calibrating your controller until the corners align with these values. Just like with shield drop notches, you want to aim for the middle of this range since any of these values will work. Once you have the notches, you can quarter circle into them, and these will be the easiest pivot tilts to do. A fun fact about the down forward tilt notches is that without UCF, you can't have them since it's better to align those corners with shield drop. Since UCF removes the need for shield drop notches, you can have both. The vertical pivot tilts are where the Gamecube controller runs into problems. For both of them, it's impossible to reach the ideal zone within a reasonable amount of time, but there's still a good method for pivot down tilt. If you quarter circle pivot into the bottom of your stick, you can take a 4-frame delay and down tilt afterwards. If you press A before waiting 4 frames, you'll get a down smash, which is why this zone isn't ideal. With pivot up tilt, the problem is that this motion will give you a tap jump. This is the hardest pivot tilt in the game, but there's still a way to do it. You'll have to use the zones of the control stick where dash overlaps with Y tilt. Because staying in Y tilt for 4 frames shuts off tap jump, if you manage to complete this motion, you'll be able to enter the top of the control stick and pivot up tilt. This is extremely hard to do, but it's the best way to do it on the Gamecube controller. On the box, the vertical tilts have been brought in line with the Gamecube controller. When a pivot is recognized and these tilts are attempted within a certain window, the A button won't work. For down tilt, the window is 4 frames. For up tilt, I decided that the box shouldn't have this option at all, so the window is 15 frames. When you're thrown vertically, the best decision is off into Ambiguous DI. This is when you DI in a manner that tricks your opponent into not knowing which side you're on, making it difficult for them to punish you. The closer you are to the ideal mix-up, the more ambiguous your DI will be. Since the box knows exactly where it's aiming, it shouldn't be allowed to pinpoint every coordinate along the x-axis, otherwise it'll be too precise. I decided to go with 4 coordinates. The 2 at the ends are the limits of x tilt, and the 2 in the middle are evenly spaced between them. With these, there's no potential for an ambiguous DI mix-up, but the box still has some decent options. The ice climbers have a bunch of hidden desyncs that you never see people perform. These are scattered across the analog stick and C stick, and they're only one X or Y value each. Box controllers have the potential to unlock tons of new options with this character, and in the future, I'll design a patch that has all of these coordinates. As far as this patch goes, it doesn't contain any of the desyncs. Earlier on, I said that it was fine for other buttons to act as modifiers, and I showed an example of where this is harmless. Here's an example of where it isn't. With Fox and Falco, it's common that you'd want to shine, then Wavedash out. Let's say you wanted to shine, then Wavedash at this angle. You'd be able to do this without moving your stick, but if you wanted to Wavedash at an angle that's in the side B zone, you would need 2 stick motions. Since I'm allowing other buttons to act as modifiers, it needs to be clarified that the B button always points in the same direction as air dodge. This rule makes it so that aiming here has to give you a side B. If you want to shine, then Wavedash at this angle, you'll have to do it manually. One of the classic risks you run when using neutral B is accidentally side B'ing. Since the box can tilt its stick with a button, it never has to run this risk, which feels disingenuous. To fix this, I made it so that when you try to tilt the stick and press B, it pushes you out of these zones and gives you a side B. What this means is that the only way to neutral B with the box is to not be holding any directions. For things like turnaround laser, you'll have to release the horizontal, otherwise you'll side B. This definitely makes it harder not to side B on the box than on the Gamecube controller, but it's better than there being no risk at all. Normally on the Gamecube controller, it's easy to point at the middle of a quadrant, but as you approach the ends, there's a risk of accidentally going into the cardinal. There's a mod that can be done to the Gamecube controller that changes this dynamic. By creating tactile feedback where the quadrants end, this risk is removed. For anyone unfamiliar with how Cardano notches work, you just go to the quadrant, then roll the stick into them. This makes it easy to do the steepest angles with the Gamecube controller. There's only one difference between the box and the notches, which is that the notches are subject to human error and degradation. This is true for all notches, but with these it'll affect just exactly how steep your Firefoxes are. Ultimately, I can't base the box's angles off of arbitrary factors. There's nothing in the rules that says you can't have 8 perfect notches, so that's what I've given it. Its angles might be a few degrees steeper than the notches due to logistical reasons, but in theory there's no advantage. Aside from that, the box is at the disadvantage of having only 40 angles compared to the Gamecube controller's 352. Sometimes you're unable to Firefox at the ideal angle. The box isn't as good as the notched Gamecube controller because of this. With the box, you're able to pinpoint the steepest Wavedash angle in the game. Between how frequently Wavedash is used and the fact that it's a movement option, this is broken and this controller should be banned if this isn't toned down. In the last section I used Cardano notches as my justification for the box having perfect Firefox angles. These notches affect Wavedashing as well, however they will not factor into my rationale for this section. When you Firefox you have nearly a second to aim, but a Wavedash has to be done instantly. The box is much better at this than the notches. At first, the box had 5 Wavedash angles, but I decided that the ones at the ends weren't realistic. At that point, there wasn't a need for more than 3. Obviously, I was most concerned with the steepest Wavedash. I started out by nerfing it by 10 degrees, which seemed fair at the time, but eventually the sad reality of this controller occurred to me. Since the box gives you 100% consistency, it shouldn't consistently hit a strong Wavedash. I had to give the Gamecube controller more of an edge, so I reduced it by another 3 degrees. At this point, only one thing left a bad taste in my mouth. These were the only arbitrary numbers on the entire controller. They were definitely around the right lengths, but I wanted to see if I could find some sort of milestones within the game. I figured a good area to take a look would be the high tier characters' ledge dashes. I would end up finding exactly what I was looking for. I first made this discovery with Sheik. Sheik wants to fall from the ledge on frame 1, jump on frame 2, and air dodge on frame 9. But Sheik will only touch the ground on frame 9 if her air dodge is within a certain threshold. If she exceeds this threshold, she won't land until frame 10. This means that it's actually better to do a shorter wave dash if you want to land faster. By pure coincidence, the coordinate I already had was the last one in this threshold. I figured I should give Sheik the option of landing on frame 9, so this finalized this coordinate. Even though this is a strong magic number for her, I don't think it matters too much. For the longer wave dash, the relevant character would end up being Falco. Falco wants to fall from the ledge on frame 1, jump on frame 2, and air dodge on frame 6. He will ground on frame 6 if the air dodge is 31.7 degrees or more, but less than that and he'll ground on frame 7. At this point, I had to make a tough decision. If I went with 31.7, Falco would hit the best possible angle on his frame 6 ledge dash. This is much more relevant than giving Sheik the magic number I showed you a moment ago. But if I went with 31.1 or less, Falco would have to use the 45-degree air dodge to land on frame 6, which is very far from his best angle. In the end, I decided that 31.7 was the lesser of two evils. Since the box is already being capped at a very average wave dash length, I'm against nerfing it any further. And with that, the box was complete. "2017 is a year that has been defined by progress. From economics to ergonomics, the Melee community has found ways to put some of its biggest issues with controllers to rest. As we've seen, the hardest part has been properly executing these advancements. I went to great lengths to create a controller that preserves hand health as well as competitive integrity. Hopefully some iteration of it is accepted by the community so that people in need can play Melee again.